Hello and welcome back to session 3 of our Nearform Presents. So, where have you been? You've missed the first 2 sessions? That's not a problem. You can catch up later on the YouTube channel for Nearform. Head over there later. You can catch the previous talks. Next up, we're going to be talking with Jonas Galvez, who will be talking about building a full stack framework with Fastify. But first, a word from Prisma, our partners.
Prisma is an open source ORM that allows you to easily manage and interact with your database. It all starts with your Prisma schema, a place where you define your database models and relations using Prisma schema language. You can write your schema from scratch, or generate it by introspecting an existing database. And when it's time to talk to your database, you'll use Prisma Client, an auto-generated, type-safe query builder where you think about your data, not SQL queries. And when your app needs to evolve, you'll use Prisma Migrate, which is Prisma's schema migration tool. All you need to do is update your Prisma schema, run the Prisma Migrate command, name your migration, and you're done. Seriously, that's it. Finally, there's Prisma Studio, an admin UI to view and edit the data inside your database. There's even dark mode. Prisma currently supports PostgreSQL, MySQL, SQLite, and Microsoft SQL Server, and works inside any JavaScript or TypeScript environment, with all of your favorite backend technologies. Prisma allows you to be more productive and ship your apps with confidence. For more info, go to prisma.io.
So hello, next we have Jonas Galvez from HelloPrint, who will be talking about building a full stack framework with Fastify. So a little bit about Jonas. He's a lead JavaScript developer at HelloPrint and a former core team member of the Nuxt.js framework. So over to you, Jonas.
Hello, everyone. Thanks for joining me. Like Katie said, I'm a lead JavaScript developer at HelloPrint. I worked for 3 years, nearly 3 years, with the Nuxt.js framework, which is a full stack framework. I worked on it long enough to have joined the core team and made numerous contributions until eventually I moved away and embarked on the Fastify train. And this started with me trying to run Nuxt on top of Fastify, and with the ever-evolving set of tools that we have for front-end development, I eventually migrated fully from it. I'm trying to migrate my projects into a more Fastify-oriented setup. So I'm going to talk about how I'm going about it, what it means for me to build a full stack framework with Fastify. But first, I want to talk about the nature of frameworks and how they are perceived. So what is a full stack framework? Wikipedia says that a framework is an abstraction in which software providing generic functionality can be selectively changed by additional user-written code tools providing application-specific software. So everyone knows that, but it's good to have a refresher as we're going through this. So this is the definition for framework. And what can we say is a full stack framework? So quick to the point definition would be a web application software framework that accounts for both the back end and the front end. So moving on, you've probably seen recently the release of the state of JavaScript, the stats from the community, satisfaction ratings, and the technologies that make up the scenario, the scene. And in the state of JavaScript from 2020, we have this list of front-end frameworks, which shows Svelte at the very top, React, Vue. Alpine is like a recent addition to the ecosystem, and many others. And we can see the list also for backend frameworks from the state of JavaScript 2020. And we see next Express, Fastify at the top, followed by Nuxt and many others. But the thing about the state of JavaScript 2020 is that I think it's missing a category. It's missing it's failing to identify which ones are actually full stack frameworks. So in that list, we can identify the full stack frameworks. The obvious candidates has Nuxt and Next and Gatsby. Nuxt for folks who use Vue has their front end framework, and Next has the one for people who use React and also Gatsby. And what makes these frameworks particularly popular, and the reason I think they should stand aside from all the rest in the list, is the fact that they enable server-side rendering with client-side rehydration by using isomorphic JavaScript. And I understand that's a lot of buzzwords and terminology. Over the past few years, those have become internalized by me and many others who are full stack developers, full stack JavaScript developers, but it's not immediately clear to many other people. So I think it's a good idea to have a quick recap on what exactly do we mean when we say server-side rendering and client-side rehydration and isomorphic JavaScript in the context of JavaScript. So there's also a Wikipedia page about it. So isomorphic JavaScript, also known as universal JavaScript, describes JavaScript applications which run both on the client and the server. And so that basically means that the code that you write and it's loaded by the browser is also run on the server for generating some sort of initial output for it. We will get to that in a bit. So Wikipedia also has an entry for hydration. Hydration or hydration is a technique in which client-side JavaScript converts a static HTML web page delivered either through static hosting or server-side rendering into a dynamic page by attaching event handlers to the HTML elements. So let's talk about that in a bit more detail using Vue as an example for server rendering and client hydration. So what you see here is a Vue component. That Vue component, we call it a single file component because it includes the JavaScript and the templates used for rendering the component. So in here we have a simple list element that's being rendered off a list variable that's added to the state of the component. And when we talk about server rendering, we need to understand that we're going to have some code that runs on the server and the very same code runs on the client. But there are differences. There are, at some point in the process, we have code that will run on the server and we have code that run only on the client. So if we're talking about server rendering this template, and we're talking about Vue, up until this point, the code that runs on the client and on the server is exactly the same. Here we have an import for a create SSR app function, which creates this special kind of app object that's SSR capable for Vue applications. Then we import the component, and we have actually, this is a typo where you see base here, it should be component. But basically, we create an app object out of the component that we imported using the create SSR app. So up until this point, the code is exactly the same. So on the client, the next step would be to mount it. And on the server, mounted means that basically it renders to the screen on the browser. And on the server, the next step would be to render it. So actually, these things are, the server part should come before the client, but basically the process would be, you load the component on the server, you use the render to string function to create a string representation of it, and that string representation is the actual markup. The client receives the markup, and once you have it on the client, what you see is that you have the pre-rendered markup that comes from the state that we have on the server, and the client received this. But since it has a data server rendered attribute, when you call the mount method for the view application, we're actually updating the state, the JavaScript state, to match the pre-rendered markup without repainting it. So the idea here is that once all this happens, your JavaScript code stays running on the client and is able to continue modifying the DOM. So once you do that rendering on the server, you load your app and you mount it with a pre-rendered markup, and you want to keep running, it has a single page application, you can. If you change the list of that component, the idea is that it would result in a visual update on the client. So moving on, so let's talk about data fetching now. How do you load the list data from an API? So there are multiple ways this has been addressed in the context of Vue and React and server-side rendering. So there is the Nuxt.js way, the classic Nuxt.js way, where for every Vue component, you have an async data method that is called asynchronously and retrieves the data needed to render the component. You have the new Nuxt.js way, which is to use the fetch method that you attach to a component. And it's able to, you can call it asynchronously, and it will retrieve whatever data your component needs to be rendered. And there's also the Next.js way, which is to use where you export get server-side props function that basically does the same as Nuxt async data and fetch. So let's talk now, what makes up a full stack isomorphic framework? Because what we're really talking about here is an isomorphic framework, a framework that allows you to write JavaScript on the server that is also loaded on the client, and you get to reuse as much code as possible. Since you are doing part of the rendering, you're doing a pre-render, so to speak, on the server, and you also need that JavaScript code to work on the client. So what makes a full stack isomorphic framework like Nuxt.js or Next.js? So I have identified 5 key features that these frameworks have, and I'm talking about Nuxt.js and Next.js because they all share these functionalities. So they have a client bundler. They can build the client bundle because nowadays browsers have amazing support for the latest JavaScript, but then not always was the case. So we have this culture where we are used to having to compile, pre-compile, transpile the client code that we ship to browsers. Nowadays, this process has become much more easier, especially if you don't need to target other browsers. Nevertheless, it has become the norm to have a build step for your client code because there are multiple things that need to be addressed, like optimization for CSS and stuff like that. You have an app server, which can serve both the API and the client bundle. And that's an HTTP server, pretty much. And you have the ability to server-side render and client-side hydrate. And you have data fetching, which provides isomorphic data fetching idioms. That means code that allows you to fetch data on the server, and the same code can be used on the client. So in the case of Nuxt.js, for instance, if you're running a server-side render Async data will run on the server, and this call will happen on the server, and the client won't have to run it again. The client will get the data, and the client will do the hydration of the data. But if you keep navigating through your app client side and you get to another component client side and it needs data, async data will also work on the client. So this is effectively an isomorphic data fetching idiom. So this is what I'm talking about here. And you also have ergonomics, like you have a CLI that's able to start up your server for hot reload for development. So these are the 5 key features that at least brought me to Nuxt.js as a Vue developer, because it provided me with a way to create Vue applications, a standard in which I could create Vue applications. So, and they have several similarities, Nuxt.js and Next.js, which are the need for a pages folder that's automatically turned into routes, and you have specific files that are identified and are automatically loaded. So perhaps an extra point here for ergonomics could be the fact that they have file system-based configuration. But I think this is enough of a good scope to start with. If we have those 5 things, we have a full stack isomorphic framework. So let's build a little framework like that. And that framework I'm calling Terex. It has been a project of mine for nearly a year now. It started at HelloPrint, where we started using Fastify in conjunction with Nuxt. And we are still working out ways to incorporate Fastify, more of Fastify, and the recent Vite build system and out of Nuxt, but that's still a work in progress. So what is Terex? The idea for Terex is to have a full stack framework built entirely on Fastify plugins. So we have Fastify for HTTP serving. We have Fastify API. That's another plugin for defining API routes. We have Manifetch, which is not really a Fastify plugin, it's just a supporting library for creating an API client from the Fastify API definitions. We have Fastify Vite and Fastify Vite View for integrating Vite's development server and bundler with Fastify. And we have Fastify Vite View for the Vue server rendering and client iteration part. And I chose Fastify CLI for the server hot reload and other conveniences that it brings. So what are some principles that I want to have for this new framework? Everything is a Fastify plugin. I want a transparent, clean architecture. I want no magic folders like .nuxt and .next, because when you use Nuxt.js or Next.js, what you have is a hidden application folder that contains most of the actual app logic. The actual source code that you have is loaded into this hidden app that it's put into a hidden folder like .nuxt or .next. So there's a lot of magic going on, and I think we can do without it. I want tight API integration out of the box, and I want to have the same open governance principles from Fastify. And also, as Rich Harris once said, frameworks are not tools for organizing your code, they are tools for organizing your mind. And that's a strong statement that I carried with myself in thinking about this stuff and designing the architecture that I see for the Terex as a framework. So in a nutshell, it's not really a framework. It's a tool for organizing your mind, and that is provided by Fastify with its solid idioms like hooks and the plugin architecture. I want it to be boilerplate first and documentation first, which basically means I want people to be able to put together an application using Terex as a framework without having to actually auto-generate pieces of code like the magic folder, and you just have individual pieces that are well documented and fall into place, and you know what they're doing and you can expand on them. So let's build this little framework, and this is what can be said to be the very MVP for such a framework, but it's not really a framework. So we can start by installing Digit, which is just a scaffolding tool that copies code from GitHub. And you can start by creating a new directory, going to it, and running Digit Terex.js framework and installing dependencies. I'm going to do that now. So I'm going to create a new directory here and cd to it. And I'm going to run Digit Terex.js framework. Right now, in this directory, I have all of the things that are in that repository. And if you look into package.json, you see that you have the dev comment, the build comment, and the serve comment, which essentially map to the same comments from Nuxt and Next.js. And it's all built on these 5 dependencies, which are Fastify, Fastify API, CLI, Vite, and Vite View. And in here you have an index.html, you have the base view component, you have the pages for the view components, and you have the entry points for that are recorded by view. So when it runs on the server, it gets to the entry server and entry point, and when it loads on the client, it gets to this entry point. So let's run npm install. There we go, npm on dev. And now we can go to a browser. Go to localhost, and there you see it. You have pieces of a single page application running, and you have data fetching, and you have some data that already came from the server. If you refresh, you see messages, hello from server. If we go to core, you see that the message, the markup comes pre-rendered with hello from server. If you go to the definition for the page, where you have message is, you see that it's actually coming from state. And the state is defined by an initial call that happens on the server and makes an API call to an API endpoint that's defined in our server. So with this little repository and these dependencies, we are able to reproduce nearly all of the core features of Nuxt.js and Next.js, which is to have, and we can go back to the presentation now, which is to have a client bundler, an app server, server-side rendered and client-side rehydrate, data fetching, and the ergonomics of a CLI with hot reload. But there's more to it. So I'm going to go over some of the details that we have now for this little framework. And one of them is Fastify Vite. I'm not sure everyone is aware about Vite.js, but it's basically a next generation front-end tooling that replaces Webpack, so to speak. Not really, but it does a lot of the things that Webpack does, and both Nuxt.js and Next.js are based on Webpack nowadays. Vite is created by Evan Yu, which is the creator of Vue, and it's a build tool focused on modern development. So you won't be able to target some older browsers with Vite, but if you're able to target the modern browsers, it provides an experience for development that's superior than what is known today. So Fastify Vite is a glue code, is a Fastify plugin that connects Vite to Fastify, and it provides a convenient way to define SSR routes and fetch data on the server. So in here we have a definition that we're saying, okay, this route is supposed to be rendered by Vite, and in this case Vue SSR. And we're also able to set an option here where we say that it needs this data to be available for the rendering. So it's a direct equivalent to Next.js get server-side props. So part of that is so in here we are defining how to fetch the data, and in here we are defining how to consume the data prior to SSR. Those are facilities provided by Fastify Vite Vue, which is an accompanying plugin. And we also provide, Fastify Vite Vue provides an isomorphic way to fetch data during SSR and rehydrate it on the client. And so in here, for instance, if it's called during SSR, it fetches the data from the server and rehydrates on the client. If it's called from client-side navigation, it fetches the data on the client directly, has an HTTP API call. And speaking of API, this setup includes the Fastify API plugin, which is a convenient way to define API routes in a way that we're able to expose them internally. So by using Fastify API, we can define API routes, and we're able to it automatically generates a little manifesto of the API definitions. And it provides a way for us to call those API routes from the API itself. So for every API method that's created through Fastify API, you have light my request method created automatically. On the client, it uses Manifetch, which is a library that uses the manifesto created by Fastify API to automatically generate an API client. That's how this is made possible. Fastify Vite Vue integrates to Manifetch. And in here, we have the rundown of package.json, which covers the things that are offered by Nuxt.js and Next.js. So we have the development server, we have a way to trigger the build, we have a way to trigger a production server. So what is Terex? To wrap up, I'm running out of time. It's an attempt to prove a couple of points. A good framework is indistinguishable from a few Fastify plugins that work well together. A good framework, and when I say framework, I actually mean a full stack isomorphic framework. It should feel like it's not even there. It should feel like just a set of well-internalized idioms. And it's a work in progress. We have some plugins that are available and made this presentation possible, but there are others who are under development, which is to have Terex as an actual CLI, Fastify Vite React for React support, and Fastify Astro for replacing Vite with Astro, which is a new build tool that's very interesting as well. Here are some comparisons. So for Nuxt.js, you end up with a node modules with 158 megs. For Next.js, you end up with 109 megs. And for Terex, which is the conjunction of only those Fastify plugins, you end up with 88. So it's a really minimal constrained setup that really has nothing else. And for the things that you need, you actually have to add on it and build on top of it yourself. So what is Terex? A potential standard for integrating SSR libraries to Fastify, glue code for developing front-end apps with Vite and serving them coupled with a Fastify backend, and just about enough complexity to account for SSR data fetching and their client-side hydration, not a bit more. So yeah, that's basically the situation here. So our roadmap is to fully support React, having an actual CLI. Export use server data has a function. That's a good idea that we can copy from Next.js. Improve API client setup with interceptors, and support Astro as an alternative to Vite. And well, we're just about the limit, and thank you for watching. This presentation will be shared eventually somewhere, and I have some links here at the top, and I can bring the focus back to my hosts.
Oh, don't worry. I got you. Thank you, Jonas. Great talk. Really interesting framework. I can't, or tool or way of organizing your thoughts, however you want to call it. But I can't wait to try it out. So thank you. Thanks to everybody for watching. We've got more talks happening, or at least one more, and then some workshops, a workshop today, and then more workshops tomorrow. So, bop over to the other stream. You got to use the little sidebar thing with the agenda, and move over to the next stream, and we will see you soon. So thanks, everybody.